Help! I need to model a linear nth-order differential equation as n number of linear first-order equations. How can this be done? Enter Dr. Halder. So you want to turn an nth-order ODE into an n number of first-order ODEs? Watch and learn. First, we need to identify the number of states. There are n number of states where n is the order of the ODE. A first order will have one state. A second order will have two states, and so on. We label these states x sub 1, x sub 2, x sub 3 until we reach x sub n. We arrange these states into a column vector called the state vector. The column vector has dimensions of n by 1. The time derivative of the state vector will take this form. This is what we are interested in. Let's look at an example of a third-order linear ODE. Our system is y triple dot plus 2y double dot plus 3y dot plus 4y equals f of t. Let's set up our state vector. x1 is equal to y. x2 is equal to y dot. x3 is equal to y double dot. Now let's take the time derivative of our state vector. We get y dot, I double dot, and y triple dot. Look familiar? We already defined x2 and x3 as equal to y dot and y double dot respectively. We can now represent our time derivative of the state vector as x2, x3 and y triple dot. Now you may be thinking, what is y triple dot equal to? This is where we return to our system. We do some algebra and get that y triple dot is equal to -4, x1 minus 3, x2 minus 2, x3 plus f of t. Plug that expression for y triple dot into our time derivative of our state vector. And this is what we get. Now all that is left to do is to construct our system matrix and control matrix so that when we do matrix multiplication, it is equivalent to the original equation. We do this by remembering what that guy Mo El taught us about matrix multiplication. Basically, you dot product this guy by that guy to get the corresponding value in the new matrix. Now we have set up the state vector and its time derivative for the example third-order linear ODE. Thanks for watching. #MAE3724, Dynamic Systems Analysis and Control.